All right, Chapter 3, Section 1. Just a quick overview of the notes. You already did these notes. And overall, they look pretty good. Just mention a couple of things here. Okay, so the graph of any quadratic function is called a parabola. The turning point of the parabola, called the vertex, is either the maximum point or the minimum point on the parabola. So you either have this low point or this high point. Parabolas are symmetric with respect to a line called the axis of symmetry. And I always abbreviate this as the AOS, axis of symmetry. This part here, you will have to identify the axis of symmetry on an assessment. So keep that in mind. I doodled up my drawing here of the parabola. If you didn't do this to yours, you probably should go back and do this. Put arrows on here. This was a screenshot from, I don't know, some kind of graphing site that I got this off of, and it didn't put the arrows on there. So draw the arrows and identify your axis of symmetry. And this point here, of course, is your vertex. That's your minimum point. Now notice the axis of symmetry goes right through the vertex. And so you're going to label the axis of symmetry with the equation of this vertical line, which is an x equals, and it's x equals whatever x is of the vertex has to be. All right, you then went on to look at the standard form of a quadratic, which is also known as the vertex form, because you can easily pick out the vertex here. HK is my vertex. Okay, remember, if this is negative, then the h is positive. If this is positive, then the h is negative. We've seen that before with circles. Axis of symmetry, again, is this line, x equals h. It's equals whatever x is the vertex, because it's the vertical line that passes through that point. Parabola opens up if my leading coefficient, the a value here, is bigger than 0, which means it's positive. And if it's negative or less than 0, then the parabola opens down. So I just say here, if it's positive, we smile or tend to smile when we're positive. And if you're negative, you tend to have like a frowny face, right? And this would be a smiley face. All right. Next part. This is a review from Algebra 2. The 5 steps here. You will need to put all 5 of these in your homework. And also you'll be asked about these 5 things on any assessment, okay? So the first thing is, does it open up or down? So you say up or down. You could tell if the A is positive or negative. Find the vertex. Well, when it's in this form, that's easy because the vertex is HK. Find x-intercepts. So if I'm looking to find a value of x, because the parabola passes through the x-axis, then, anywhere on the x-axis that a point is, the value of y is 0. So replace f of x or the y with 0, and then solve it for x. Find the y-intercept by replacing x with 0. You're really finding f of 0 to find the y-intercept. The y-intercept is f of 0, right? Because your ordered pairs for y-intercept is always 0, y, which some of us are still having issues with writing the y-intercept as an ordered pair. And this is part of the reason why I want you to, so that you know that the x component of any y-intercept is always 0. Okay, then the next thing you do is, yes, you plot the intercepts and the vertex and you connect with a smooth curve. But this number 5 here also includes giving the equation for the line of the axis of symmetry. Okay, and we will typically draw that with a dashed line because it's not part of the graph. Well, anyway, it's not part of the parabolic function. All right, graph the quadratic function. Here, remember, you are to use checkpoint examples in your notes. Checkpoint examples only. No sense in copying what's already in the book. That's not making you think. And so when you are assigned to do your own notes, it has to be the checkpoint examples. All right, show the 5 steps in your notes. Number 1, this thing opens down. Why? Because that is negative. The vertex is not -1, +1, and actually +4. There's my vertex. X-intercept. Folks, if I'm on the x-axis, the value of y has to be 0. So replace the y with 0. You know, this y, okay? 0 equals this. And that's what I did right here. Okay, set it equal to 0. And then you solve this for x. You have to get x out of this parenthesis prison here. Okay, so I took this chunky monkey to the other side to make it go positive. The 4 stays positive. Take the square root of each side. X subtract 1 equals positive or negative square root of 4. Of course, the square root of 4 is 2. I'm going to add the 1 to the other side so I get to x-intercepts. And folks, all of your intercepts must be written in terms of an ordered pair. Okay, so if you didn't do that in your notes, please go back and do that. The y-intercept, you're always finding f of 0 when you're looking for the y-intercept. So you replace every x with a 0 and you compute this. And here again is my ordered pair, the y-intercept. Axis of symmetry, that goes back up to the x value of the vertex. It's always an equation, not sometimes. It's always an equation of a line because it is a line. It's this line right here, right? Because you have corresponding points. This point here and this point both correspond, meaning this point is 1 unit to the left of the axis of symmetry. Its corresponding point would be 1 unit to the right of the axis of symmetry. This point here is 2 units to the left of the axis of symmetry. So its corresponding point would be 2 units to the right of the axis of symmetry. And here, down here, I have, you could recall your transformations of functions to see if you have graphed this correctly. This is your parent function, x squared, shifted 1 unit to the right and up 4 units, and then flipped upside down. So 0, 0, 1 to the right, up 4. Yes, it does work. Okay, if you have any questions on that, please let me know. The next checkpoint example was this one, quantity x minus 2 squared plus 1. Again, we're not graphing with transformations. We are actually doing this 5-step process. So you have to first say, does it open up or down? Well, leading coefficient is +1, so it opens up. The vertex, easy peasy, 2, 1. Right there it is in vertex form. X-intercept, remember you let the y be 0, and then you solve this. Now, these are not real x-intercepts. And in fact, this parabola does not pass through the x-axis. And this is why I wanted you to do the checkpoint example on this one, because I don't think the regular example showed this. And so, you're still going to show me that they are imaginary roots. You're not going to put it in ordered pair form because it's not a number on the number line, but I still want you to show me this. All right, the y-intercept. Anywhere on the y-axis, you let the f be 0, so you find the f of 0, and then here is my ordered pair, 0, 5. So I plot that. I found the vertex. I now am going to draw my line for the axis of symmetry. Going to give my equation for the AOS. Usually it's customary to write it up here, x equals 2, for that line. Okay, since this point right here is 2 units to the left of the axis of symmetry, its corresponding point would be right there. And now I have enough to draw my curve. All right, so don't forget about this part here. You need the equation for the axis of symmetry. All right, so the vertex of a parabola whose equation is in this form, which is what we call the general form or expanded form, you've got to use this negative b over 2a, comma, f of negative b over 2a. This negative b over 2a, I spoke about this in the Google Meet, that this comes from your quadratic formula. The square root of b squared minus 4ac, that represents the discriminant, and then this negative b over 2a represents the x component of the vertex. So we do the same thing this is still a in the front here, right? Because it's ax squared. So if the a is greater than 0, it's positive, right? Then it opens up. And this is positive 1, so it opens up. Vertex. This is not in vertex form. However, you could complete the square, which is what I show here, on the bottom page of my notes. I'll scroll back down there for you so you can take a look at that. But when it's in this form, you need to know this little baby equation. Do I give this to you on a test? I don't think I do. All right, so just remember that x is equal to negative b over 2a. Folks, this is your a. Your a is 1, your b is negative 2, and your c is negative 3. All right, so you need the a and the b. Substitute it in here. Compute it carefully. Watch you don't make any sign errors. All right. Once you get what x is, then you have to find f of this. You have to find f of 1 to get the y that goes with it. And we see here that our vertex is 1, negative 4. All right, so we're opening up and we're at 1, negative 4. So we go to 1, negative 4. You put a point. Okay. I want x-intercepts. That's the next logical thing. If I'm on the x-axis, the value of y is 0. And then this you factor. I saw many of you use the quadratic formula. You didn't have to use quadratic formula for this, because this factors. If it factors, factor it. The only time you want to use QF or complete the square is if this does not factor. So make your job easier and quicker by factoring. Okay, and here are my x-intercepts. They have to be in ordered pair form because they are points on a graph. And so we're going to dot those in. Okay, and then we need this y-intercept point. Okay, that's finding f of 0, getting an ordered pair 0, comma, y-intercept. Okay, and that's this point right here. I know my axis symmetry goes through the vertex, so I draw it and identify the equation for the axis of symmetry. Since this point here is 1 unit to the left of the axis of symmetry, its corresponding point would be 1 unit to the right. And so now I've got some points that I can connect with a smooth curve. Again, here, I could take, just to check, all right, I could take my original equation and complete the square with it, right? I boot the constant over, take half of this. This is my plus 1. I got to add 1 both sides. This is a perfect square trinomial. But then to get the vertex, you got to have all this stuff on one side. So you do see that the vertex here is 1, negative 4, which is what negative b over 2a, comma, f of negative b over 2a gave us. All right. Last thing to do in this section was they were talking about, a minimum or a maximum, and then, of course, the max or min value. So what's important here is that the function has a minimum or a maximum at the x value. So x is saying, hello, I'm here. I'm making this happen. Okay, it's because of me. So it's happening at the x value. Right? But what is the actual max or min value? Well, then that's the y. Okay, so if it says, where does the min happen? Well, it happens at the x coordinate. And then what is the value of the min? Well, then the value of the min would be the y. All right, so here, application problem. You've already read through this. Hopefully you got this correct and checked your answers in the back of the book. The function f of x, and here it is. I'm just going to put a box around it instead of reading it. Models the number of accidents per 50 million miles driven in terms of a driver's age, x in years. So x represents the driver's age here, okay? Where the ages are between 16 and 74, including 16 and 74. What is the age of a driver having the least number of accidents? And what is the minimum number? So I am looking for a min here, which is an indication that this problem is looking for the vertex coordinates. It's vertex because this thing is quadratic. Okay, so quadratic either, if it opens up, we have a min. But if it opens down, then we have a max. Okay? And so, when you're reading the problem, you look at it and say, oh, it's quadratic, it's a parabola, I'm looking for a max or a min, I need the vertex. And because this is not in vertex form, and I don't think I'd be wanting to complete the square with this, we've got to use this little model here, this little formula, if you will, that helps us find the x. Okay, and once we get the x, which in this case happened to be 45, then we're going to find f of 45 to find that minimum number of car accidents, or that min value. Okay, so the min happens at 45 years old, and the min value is 190 accidents per 50 million miles driven. Don't forget, these are application problems, and you have to give your answer in terms of a sentence. Okay, so if you have any questions, please ask. I have a homework discussion. You can ask me in class, or if you're at home, pop into the Google Meet so that I can help you, or send a message or something. I prefer the homework discussion because I do get a message that there's something there for me to look at. And then others can share in, any kind of response that I may give to that. All right, make sure that your graphs are all on graphing paper. Have a great day.